So there's this quiet revolution happening right now in medical labs all over the world. It's being powered by AI, but this isn't some sci-fi story about robots taking over. It's actually about totally rethinking what it even means to be a medical expert, from the ground up.
Let's just get right to the big question on everyone's mind. You know, whenever AI steps into a super skilled field like medicine, there's always that one huge question hanging in the air, right? Are we about to see human experts get replaced? Is this the end of the line for these professionals?
But what if we're asking the wrong question entirely? See, the real story here, the one we're going to dig into, isn't about replacement at all. It's about transformation. How is AI going to fundamentally change the day-to-day, the identity, the very job of a clinical biochemist? That's the really fascinating journey we're about to go on.
All right, so here's how we're going to break this all down. We'll start with the data explosion that's happening in modern labs. Then we'll see exactly where AI is stepping in. We'll weigh the pros and cons, the risks versus the rewards. Then we'll meet this new kind of biochemist. And finally, we'll map out a realistic path to get there.
Okay, let's dive right in. First up, the data-driven lab. The thing you have to understand about modern labs is that the problem isn't a lack of information, it's a total and complete flood of it.
I mean, labs have always been about data, right? But what we're seeing now is on a completely different level. It's not just a stream of information anymore, it's a tidal wave. These high-speed machines are just pumping out these huge, complex data sets, way more than any human could possibly sift through on their own.
Now, imagine trying to handle that tidal wave of data inside a pressure cooker, because that's the reality. Labs, and this is especially true in places like India, are being asked to do way more with way less. More tests, fewer people, and tighter budgets. So when you mix that data overload with a lack of resources, well, suddenly AI doesn't look like some futuristic luxury, it starts to look like a lifeline. And that's the perfect lead-in to our next section. So where is AI actually jumping in and helping out? Well, it's not just in one spot. It's getting woven into the entire testing process, which we can really think of as having three main phases. Probably the easiest way to think about any lab test is like a little three-act play. Act 1 is the pre-analytical phase. That's everything that happens before the test even starts. Act 2 is the analytical phase, that's the test itself. And Act 3, the post-analytical phase, that's all about making sense of the results. And here's the kicker. AI has a starring role in every single act. So, in that first phase, the pre-analytical one, you can think of AI as the ultimate gatekeeper. Its whole job is to stop mistakes before they can even happen. It'll flag a weird test request from a doctor, it can spot a potential typo on a sample label, it can even look at the quality of the sample itself and say, hey, something's not right here, all before a single test is even run. Okay, now for Act 2, the actual analysis. Here, AI becomes this super vigilant supervisor that never sleeps. It's watching the instruments in real time, catching these teeny tiny little drifts in performance that a person would just never spot. And this is huge because it's not just about finding errors after they happen, it's about predicting them so you can do maintenance before anything goes wrong. And then we get to the final act, post-analysis. Here, AI really acts like a smart filter. It takes this massive, messy stream of raw results, and poof, it automatically verifies all the normal, boring ones. That leaves only the tricky, complex, or unusual cases for the human expert to look at. This means their time and brainpower are spent where they matter most.
So, I know what you're thinking. This all sounds amazing, right? Almost too good to be true. But, with any powerful new tool, it's never that simple. So for our third section, let's talk about the other side of the coin, the double-edged sword, the very real risks that come with all these rewards.
And really, this is the core dilemma with AI in medicine. On one hand, the promise is absolutely incredible. Automating boring tasks, getting faster results, finding patterns we'd otherwise miss. But on the other hand, the dangers are just as real. What happens if we become so reliant on these tools that our own skills start to fade? And who's ultimately watching the watcher? Who's supervising these incredibly complex systems?
Okay, so to deal with all this, we obviously need some rules of the road. We need governance. And that means tackling some really, really tough questions. Like, can we make these algorithms transparent? How does this thing actually work? Can it explain its decisions? Why did it spit out that result? And the big one, if it messes up, who's accountable? Who takes the fall? Organizations like the Indian Council of Medical Research are starting to map this out, but man, it's a monumental task. All right, so we've got these incredible possibilities on one side and these serious risks on the other. This brings us right to the heart of our story in Section 4, the reinvention of the expert.
What does a biochemist actually look like in this new AI-powered world?
This right here is the fundamental shift. The job is evolving from what you might call an analyzer custodian, basically someone who just oversees the machines, to something much more dynamic, a clinical knowledge partner. So instead of just rubber stamping routine reports, they become the translator for these complex algorithms. Instead of being siloed in the lab, they're out there collaborating with doctors. The job goes from rule-based and repetitive to strategic and essential.
Now, to make that jump, you need a whole new skill set. And at the center of it is something called AI literacy. And let's be clear, this is not about turning every biochemist into a coder. Not at all. It's about having a deep, practical understanding of what the AI is good at and, just as importantly, where its limits are. It's about being able to interpret the results with a critical eye and explain the nuances, the uncertainty, to the doctors making the final call.
Because at the end of the day, this is the key takeaway. The most critical skill in this whole new world is still 100% human. It's that unique ability to take a piece of raw data from an algorithm and translate it into a meaningful, clinically relevant recommendation for an actual patient. You have to anchor it in that deep knowledge of biology and disease. The AI gives you the what, but the human expert, they provide the so what. And that makes all the difference.
Okay, so this all sounds great in theory, but how do we actually do it? How do we get from here to there? For our final section, let's get practical and look at a roadmap for making this happen, using the situation in India's labs as a great example.
And the great news here is that this isn't some all-or-nothing, flip-a-switch kind of change. It's a gradual process, and different labs can get on board at their own speed. You've got your big corporate labs. They can be the trailblazers, right? They can pilot advanced AI for quality control and automation. But at the same time, smaller labs or public sector ones don't have to be left behind. They can start with simpler, high-impact tools, like basic digital dashboards or smart testing protocols. It's all about building a foundation.
But of course, building this future isn't just about the tech. It's about people, and it's going to take a real team effort. We have to update how we teach, bringing data science and informatics right into medical training from the get-go. We've got to break down the silos and get lab experts, clinicians, and data scientists all talking to each other, collaborating. And maybe most importantly, we need leaders with a clear vision who can actually champion this integration and guide their teams through the change.
You know, when you boil it all down, it really comes back to this one powerful idea. The success of a lab in the future isn't going to be measured by how fancy its algorithms are or how complex its machines are. It's going to be measured by the wisdom and the diligence of the human experts who apply those tools for the benefit of the patient.
So you see, this whole time, it was never really a story about humans being replaced. It's a story about the human role being elevated. By embracing AI as a partner, the clinical biochemist's job becomes more strategic, more interesting, and frankly, more critical to patient outcomes than it has ever been. It's a massive opportunity, not something to be afraid of. And that leaves us with one final thought to chew on. As these powerful tools become more and more a part of all of our professional lives, what's it really going to mean to be an expert in the future? Is it about being a master of the machine or a master of its meaning?